Right. Good evening. This is VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South, and just doing some adjustments here as I go. Let me just check my audio on HF. 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5. I think that's doable. 1 2 3 4 5. Check 1 2. All right. 1 2 3 4 5. I think that's good. 200 watts. All right, take that off. Good evening, everyone, on this 5th of September 2025. I think it was possums, a funny noise outside all of a sudden. Yeah, two possums are fighting. There's been some funny noises around here tonight. More ways than one. VK3 CSJ on the microphone. Clint Jeffrey, your host. And I hope everybody is feeling okay and looking forward to the long, it's a long weekend. It was a long weekend last weekend for me. To this weekend anyway. Happy Father's Day to all the fathers out there. I think it's this Sunday. So if you're a father, happy Father's Day for what it's worth. And here we are. I was actually that close to not doing it tonight. I was, in fact, went looking for my email that generally has 43 emails attached to it. Some of those don't work, but I was about to put out a little bulletin saying, nah, I'm not doing it tonight. But suddenly I thought, nah, what the heck. So here I am. We've got a report from Timothy Scove, our space weather woman, tonight, although it's a bit late. It's her predictions go out to Friday today. So it's going to be a fill-in, just to fill it in some time. And how long does it go for? Goodness me, it's a 17-minute report. So we'll show it more to do with historic aspect, which I've done before. But anyway, there it is. What else? I very quickly put some articles together tonight. I might just start off by recapping the sky notes from Tanya Hill, the resident astronomer at the planetarium, just very briefly go over some dates I haven't mentioned. Then I'm going to jump to a quick article to do with before spacecraft, how did astronomers determine the mass and size and composition of giant planets? You might have wondered that. And then there's something on Mars. Underground preserves its ancient past. And then I jump to scientists seek to discover what became or what came before the Big Bang. And a quick one on some asteroid fragment that reveals a strange mineral never seen on Earth before. And if I've got time, I might just do a quick recap on what is redshift and blue shift when it comes to astronomy. And then we'll jump in somewhere in there. I'll throw in Tamitha's report, probably before the spaceweather.com report. And I think that's about it, really, in the scheme of things. So let's get on to this. We're broadcasting on the prime frequency of 3541 kilohertz in the 80 meter amateur radio band. And we're also broadcasting live to the Melbourne television repeater, VK3RTV Digital Channel 1. Good evening to all the viewers there, or probably one or two. And what else? We're streaming on 2 streams, and one's my YouTube channel for what that's worth. That really needs to be cleaned up, that channel. A lot of junk on it. But yeah, just go to VK3CSJ, search for VK3CSJ, and look for the live indicator, and that'll be me. So hopefully for the next hour, I'll be there before the modem falls over. We also have Discord. And as I have maintained for a long time now, that Discord is the way to view the stuff here, apart from Melbourne TV repeater, because whatever I show, graphics and vision and live stuff, is less than a second delay, what you're hearing on 80 meters. Now, if you can put up with a 20-second delay on YouTube, that's fine. So if you go to qrz.com and look up VK3EKH and VK3CSJ, somewhere amongst all the text, I throw in a little URL link password. That's not a password, but it's a link that gets you to the astronomy chat room on Discord, where everybody is, and also the HD channel if you go searching for it. Anyway, it's HD. I'm paying for that HD capability on Discord. Otherwise, it'd be SD, pretty ordinary. All right. What else is there? I think that's about it. So we shall go into this usual thing. The ASV. This particular broadcast, for those that might be tuning in for the first time. This is a regular Friday night broadcast on behalf of the Astronomical Society of Victoria, because the ASV has its own call sign, radio call sign, which was obtained back in 1988. And so therefore this particular Friday night broadcast on this particular frequency has been running since 1988, and I've been doing it for the last 12 years. So, might even be more than that now. But still, we're here. I was barely here tonight. Alright, the ASV, yes, that's where I was, is a non-profit society for people interested in astronomy, attracting and catering for people with a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. Well, it's about 1,800 now, or more actually. Its activities are coordinated by a council of elected office bearers, section directors and councillors. The ASV has weekly activities at our 2 metropolitan locations, the Morley Community Village and the Melbourne Observatory. And we host monthly astro talks at the Herbarium near the Melbourne Observatory. If you can't make it to the observatory, to the Herbarium, usually there is 2 video streams, one to the ASV YouTube channel and one to the Facebook ASV channel. The Society's library is also located at the Melbourne Observatory and is open during our Astro Talks. For over 50 years, the ASV has played a major role in the care of the buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for the people gatherings throughout the year, bringing telescopes and astronomy to Melbourne parks and schools. And it says here to check the online calendar for details of upcoming events that you might be able to attend. The ASV is currently involved in a number of major projects. This needs to be updated, really. We are involved in the restoration of the Great Melbourne Telescope, ongoing, and also currently working on the installation of a series of remote telescopes at our dark sky site, which once complete will be accessible to members for use. Well, as far as I know, all those remote domes that are up for our dark sky site are now functional and are accessible to members on request or something or other like that. But what's not mentioned in this is that there is an ongoing new construction out at Western Victoria, where there is a whole bunch of slide-off roof type observatories being built, and through the ASV, through a membership of the ASV, you can hire a roll-off roof to set up your telescope for 1 night, 2 nights, a week, depends on how long you want to do it. But it's a totally secure and protected environment. But it is in virtually Bortle 1 skies. The viewing at this location is superior. So the ASV is going full hilt on getting this particular project complete. Probably by the end of the year it will be pretty much done. Anyway, thanks to the generous donation of one of our members, the late Leon Mao, who donated the 30 hectares, I think it's 30 hectares, 30 hectare site up there at Heathcote to the ASV. It's called the Leon Mao Dark Sky Site, LMDSS, and that's located, like I say, just north of Heathcote. And even that particular site is still pretty good for looking at the sky at night time. Last time I was up there. But the glow from Bendigo is slowly encroaching on the west, and there's fairly decent glow, predominant glow in the south, which is mostly lights from Heathcote, but most likely also a percentage of that's from Melbourne. So yes, this is where this new site out at Centre Western Victoria is looking good if you really want a dark sky site. Anyway, and I just had a quick look at the all sky camera just a moment ago, but it is not looking good at the moment. Where was that? If I go there quickly, so for those people watching video, can see what the all sky camera is looking at. It's actually not much to see really. That is, for those watching the visions, that's the view from our all sky camera. So in fact the dome, the glass or acrylic dome is a little bit got some moisture in it due to humidity and whatever. The moon is in full flight. That's what the glow is in the middle of the screen. It's not a UFO. And so the moon is in full flight, so not much observing tonight, unfortunately. Can be done by optical astronomers. But you can tell that the sky is a bit cloudy. And yeah, not a place to be at the moment. But nevertheless, having said all that, we get back to here. So yes, up at the Leon Mao Dark Sky site, the ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair-accessible 16-inch telescope. There's also a fully steerable 8.5 metre, a 30-foot DSD Kennedy dish antenna being used for radio astronomy, and that's fully functional and can be accessed if you get involved with the radio astronomy section. And a very pleasant good evening to any RAS members that might be listening. I know John is. G'day, John. There's also an annual yearbook is supplied to members, as well as a bi-monthly newsletter called Crux, which all members are welcome to contribute to. There always are for articles for the ASV magazine. The ASV logo shows the Southern Cross and the pointer stars, and there is a little Latin insignia which, when translated, is "This way to the stars." The ASV is governed by a set of rules which should be read before applying for a membership, and there is a link on the ASV website under where it says ASV rules, and you click on that and more information will be revealed. The ASV website is www.asv.org. That is www.asv www.asv.org.au, or just type in Astronomical Society Victoria in your favourite search engine. I think I coined that expression some time ago. Now, it's coming up to, where's our calendar? On the, let me just make sure I get the date right. On the 10th, what's the date today? The 5th. So we're there. So yes, next Wednesday is the Astro Talk. And I think it was an email that I read somewhere that there won't be, I don't think there will be any presentation at the herbarium, but I think this particular Astro Talk will be mostly online. I think that's the case. But it is presented by Dr. Jacob Crosset. Oh, don't sneeze. My nose is playing up. The presentator, the speaker, is Dr. Jacob Crosset, and they are talking, because I'm not sure if it's a he or a Jacob, it's got to be a he, I suppose. The topic of conversation is the jellyfish galaxies. That's all I can tell you on it at the moment. There's no other synopsis on this presentation here. But I'm looking at this under the calendar on the ASV webpage, so you can check it out for yourself. But yes, next Wednesday at 8 o'clock is a presentation by Dr. Jacob Crosset on jellyfish galaxies. And if I remember, I will try to link into the YouTube stream and run it on the repeater, ATV repeater here on this channel. So that's next Wednesday. But the this particular calendar, it also gives you the YouTube link and the Facebook link and the Twitch link. I didn't know there's a Twitch link, but there's a Twitch link. So there's 3 links there that you can use to view the streamed vision. All right, so that's the ASV in a nutshell. Let's see, just quickly jumping to Tanya Hill, Sky Notes, and I'll bring up her picture there, sitting in the planetarium. Oh no, that's over. I won't do that. So there's Tanya Hill, lovely lady. Sky Notes. The first part of the Sky Notes, she talks about a new camera for new astronomy. It's I haven't actually been able to find that much more information on it, but it says here that researchers at the Indian Institute of Science have developed an eye-like or neuromorphic camera better able to detect fainter and faster moving objects than the conventional charge coupled devices or CCD cameras. Experimental results include the faint star Sirius B seen alongside its far brighter companion Sirius A, a high velocity meteorite passing near the bright moon, and a small moon orbiting Saturn and its bright rings are some of the images which I showed last week. But essentially they're saying that this new camera its responsiveness is equivalent or very similar to the way the human eye works. So looking forward to seeing more from that. I don't think I need to mention that right now. Well, the spring equinox in the southern hemisphere, we're about to experience the spring equinox, which is Tuesday the 23rd. So it's still a little ways off, but Tuesday the 23rd. Jumping down there, what is the date? Today it's 5th. So yep, sunrise. 3 sunrise dates. Thursday the 11th. Sunrise is at 6:27. Setting at 6:07. Sunday the 21st, sunrise is at 6:11 a.m, setting at 6:15 p.m, and by the end of the month, its sunrise will be at 5:57 a.m, setting at 6:03 p.m, with the day getting progressively longer. The moon phases. This Monday, coming Monday, yep, there's a full moon on Monday. There's a third quarter on the 14th. There's a new moon on the 22nd, and the first quarter on the 30th of the month. Yep, okay. Briefly, planets. Mercury is soon to pass behind the Sun and is not visible this month. Venus is just still visible in the east from 5 a.m. in the morning. Mars is soon to move behind the Sun for its solar conjunction and will remain Mars is soon to move behind the Sun for its solar conjunction, but will remain visible this month from 6:50 p.m. in the west until it sets by 8 p.m. Jupiter has now passed behind the Sun and can now be seen rising in the east around 3:30 in the morning. Saturn is nearing opposition and can be seen rising in the east at 8 p.m. and transversing the north until being lost from view in the west by the dawn. Meteors. There is a meteor shower this month. It's called the Southern Pisces, Southern Pisces. It will be in the constellation of Pisces, the fish, the radiant. It is slated. The date is slated between the 11th and the 20th of this month. Usually they usually only number a few per hour and appear in the constellation of Pisces, the fish, which rises in the northwest from midnight. Probably not much to see unless you're in a dark sky location. I won't worry about all that. Neither that. And I'll mention just a few dates. Where was I? I don't know whether I read out any dates last week. I might have, I can't recall. Anyway, the 5th of September 1977, being today, 1977, Voyager 1 is launched to explore the outer solar system. After 42 years, it continues sending data and is the most distant probe at 21.8 billion kilometers. On the 8th of September 2004, Genesis probe crashes in Utah while returning samples of solar wind particles. Some collecting panels survived impact and were recovered, giving successful scientific results. On the 11th of September 1985, the International Cometary Explorer, ICE, became the first spacecraft to encounter a comet by flying through the dust trail of a comet. On the 14th of September 1959, Luna 2, USSR, was the first craft to fly to and impact another body, in this case the Moon, and it released sodium gas to allow visible tracking and used radio for telemetry transmission before crashing on the surface. I think I remember reading that out last week. On the 17th of September 1976, NASA unveils its concept for a space transportation system. That was 1976, and it was eventually known as the Space Shuttle. On the 21st of September 1633, the Roman Catholic Inquisition begins a trial of Galileo for heresy in publishing and advocating the heliocentric or sun-centered solar system contrary to church doctrine, dogma, and scripture. And you know, from what I read somewhere, that hadn't changed until some date in 1983. The church still had some reference to a not believing in the sun-centered solar system. I find that hard to believe, but anyway, it was something like around 1983 that they finally decided to upgrade their records. It was something like that. I need to confirm that. All right, and the last thing here is on the 27th of 1905, 27th of September 1905, Albert Einstein published his paper containing the famous equation E equals mc squared, where energy equals mass multiplied by the speed of light squared, meaning a small amount of matter or is equivalent to or can be converted into a great deal of energy. I think we know about that. Okay, I think that's it in a nutshell. And now we shall jump into the next article. If I can just get vMix to show it to me. Where are we? Go here first, go there next, right. Oh yes, so I shall bring up a lovely little picture of Saturn. I think I've got it here. Maybe not. It's always something. Alright, just a sec. I am sure that I did download this image. It is an image. It is there somewhere, and there it is, and I didn't bring it across. So stand by. We're just about to bring up this beautiful image of Saturn. There we go. Lots of key clicks. Mouse clicks. Isn't she a gorgeous planet? Anyway. At 10:27, this is VK3EKH. Before spacecraft, how did astronomers determine the mass, size and composition of giant planets, you might have thought and wondered. Prior to flybys, scientists used mathematical laws and observation to determine the characteristics of these distant worlds. It's an excellent question. Astronomers are often faced with seeking information about objects they cannot visit to examine. Instead, they use mathematical laws and observation to determine the characteristic of planets. Determining the size of a celestial object is relatively straightforward, provided that one knows the object's distance and the angle it subtends from our viewpoint. Even though the planets Jupiter and Saturn have been known since antiquity, their distances in terrestrial units, i.e. miles or kilometres, weren't reliably determined until the 18th century. Astronomers used two transits of Venus in 1761 and 1769 to first measure the astronomical unit, or AU, in terrestrial units. 1 AU is defined as the mean separation between Earth and the Sun, or 150 million kilometres. Prior to these measurements, Kepler's third law, in 1619, enabled astronomers to determine the distance to other planets in terms of the AU, but not in terms of terrestrial units. For instance, astronomers knew Jupiter's average heliocentric distance was 5.2 AU, 5.2 times farther from the Sun than the Earth is. And once the AU was determined in miles, so too were the distances to Jupiter and all other known solar system worlds. This information, combined with observations of the planet's angular diameters, which are readily discernible with a telescope, yield direct measurements of their sizes. Ascertaining a planet's mass requires nothing more than an orbital body, e.g. the Moon. Fortunately, the outer planets have these in abundance. Astronomers can use Newton's 1687 modification of Kepler's third law to determine the mass of both apparent body and body in orbit around it. And there is a little formula here which I did copy. This is the equation that they were about to talk about. So this is it. Newton's 1687 modification of Kepler's third law to determine the masses of both apparent bodies and a body in orbit around. And that's it. Where P is the moon's orbit period, G is the gravitational constant, M1 is the planet's mass, M2 is the moon's mass, and A is the mean separation between the planet and its moon. By measuring a moon's orbital period and determining the separation from its planet, one can calculate the combined mass of both bodies. Fortunately, the mass of the moons tend to be hardly noticeable in relation to their planets. The Earth's moon is a notable exception. So in the case of outer planets, the measurement of both masses essentially yields the planet's mass. Jupiter's 4 Galilean moons were discovered in 1610. Saturn's moon Titan was discovered in 1655. William Herschel discovered Uranus in 1781, and in 1787 also discovered its moons Titania and Oberon. Titania and Oberon. William Lassell discovered Neptune's largest moon, Triton, in 1846. Very soon after the planet itself was discovered. As soon as astronomers were able to measure the orbital periods of these moons, they could determine the mass of the planets around which they revolved. And as for composition, astronomers can identify chemicals in the atmosphere of other planets through spectroscopy or analysis of their light broken up by wavelength, called a spectrum. When astronomers observe the sun's spectrum, they see a series of dark lines located at specific wavelengths. These dark lines are produced by absorption of protons by the chemicals present in the outer regions of the sun. Each chemical produces its own unique absorption spectrum. Think of these absorption patterns as akin to barcodes, each of which is associated with a given chemical. We see the planets because they all reflect a portion of the sunlight they receive out in space. That reflected light, when split into a spectrum, also includes dark lines produced due to the absorption of light by chemicals in the planet's atmosphere. This reflected spectrum yields some direct information about the chemical composition of outer planets' gaseous atmospheres. So, that was courtesy of astronomy.com, published August 18. You're tuned to ASV Radio, VK3EKH, and the next article here is to do with Mars underground, and there's a nice little picture here of the probe on the surface of Mars, which is here somewhere. No, I didn't bring that across either. Hang on a sec, let me just do that. Image, browse, there it is. And bring that up. Okay, this is what we're talking about now. The red planet's mantle is giving scientists clues to its geological history. Published September 4. This image on the screen right now is NASA's interior exploration using seismic investigations. It's called the InSight lander, which was launched towards Mars on May 5 and landed November 26, 2018. It continued to operate and send back data for more than 4 years. A planet's mantle, the vast layer that lies sandwiched between its crust and the core, preserves crucial evidence about planetary origin and evolution. Unlike Earth, where active plate tectonics continually stirs the mantle, Mars is a smaller planet with a single plate surface. As such, its mantle undergoes far less mixing, meaning it may preserve a record of the planet's early internal history, which could offer valuable insights into how rocky worlds form and evolve. Using data from NASA's InSight lander, Constantinus Columbus from the Imperial College of London and his colleagues studied the seismic signatures of Mars quakes to better understand the nature of Mars's mantle. By analysing 8 well-recorded quakes, including those triggered by meteorite impacts, the team discovered that high-frequency P-wave arrivals were delayed as they travelled through the deep portions of the mantle. P-waves, or primary variations, about a kilometre across in the makeup of the planet's mantle. Because Mars lacks plate tectonics and large-scale recycling, these small-scale irregularities must instead be remnants of its early history. Whereas Earth's early geological records remain elusive, the indication of preserved ancient mantle heterogeneity on Mars offers an unprecedented window into the geological history and the thermal chemical evolution of a terrestrial planet under a stagnant lid. The prevalent tectonic regime in our solar system, write the authors. This evolution holds key implications for understanding the preconditions for habitability of rocky bodies across our solar system and beyond, they say. The scaling of Mars's mantle diversity suggests that it came about as a result of highly energetic and disruptive processes. They include massive impacts early in Mars's history, which fractured the planet's interior, mixing material from the crust and from space into the mantle of at a planetary scale. Moreover, the crystallization of vast magma oceans generated in the aftermath likely introduced additional variations. Instead of being erased by plate tectonics and other forces, these features became frozen in place as Mars' crust cooled and the mantle convection stalled. And that was courtesy of Astronomical. Mars Underground preserves its ancient past, September 4. Where are we with the time? Okay. You're tuned to ASV Radio, VK3EKH. This next article is titled Scientists Seek to Discover What Became Before the Big Bang. And there's only one graphic that they have for this. It's a pretty ordinary looking graphic, but there it is. Oh, I've got my call sign up. I should be with the Astronomical Society one. Get rid of that. Anyway, sorry about that. Righto. This article is that long, so it won't take long. I'm going through them too quickly, I know. This is courtesy of astronomy.com, and I might just bring up my insert. There we are, so there I am. Scientists seek to discover what came before the Big Bang. Here's how computers' simulations of space-time are pushing the boundaries of science, published August 28. A team of scientists claims a computational tool for studying black holes' collisions could be our best bet for answering the mysterious questions about the universe's origins. In a paper in Living Reviews in Relativity, they argue for applying a technique called numeral relativity to peer into the moment before the Big Bang. At its heart, numeral relativity is the art and science of developing computer algorithms to solve Einstein's equations, as defined in the textbook Numeral Relativity. It brings Einstein's theory of general relativity to life inside a supercomputer when gravity becomes too strong for equations to be solved by normal methods. The paper is authored by Eugene Lim, a cosmologist at King's College London, and Katie Clow, astrophysicist at Queen Mary University of London, and Yosei Yuroki Texter, astrophysicist at the Oxford University. Ah dear. Their proposal aims to solve a fundamental problem for cosmology. For decades, our cosmological model has relied on a crucial simplification that the cosmos is homogeneous or smooth and isotropic, the same in every direction. While this has been incredibly successful, it hits a wall at the universe's origin because of its singularity. This is a theoretical point of no return, where, as the August 20 press release describes, there is a state of infinite density and temperature where the laws of physics collapse. The simplified model that works so well today is useless in the face of such chaotic beginning. Because of these limitations, a more powerful tool is needed. Numeral relativity has already proven its value. Computer simulations using numeral relativity predicted that the merger of two black holes would be possible according to Einstein's theory and would release a powerful burst of gravitational waves. Then, in 2015, the LIGO Observatory detected the signal from such a merger for the first time, confirming both Einstein's century-old theory and the remarkable utility of numeral relativity. This success makes researchers confident that numeral relativity can tackle these new cosmic mysteries. Traditional methods require simplifying the universe to make the math manageable, but numeral relativity is built to handle the full, messy reality of Einstein's theory. Cosmologist Eugene Lim likens it to searching in the dark. You can search around the lamppost, but you can't go far beyond the lamppost where it's dark. You just can't solve those equations. Numeral relativity allows you to explore regions away from the lamppost. The team's confidence stems from the method's past triumphs. They believe its successes in simulating black holes mergers proves the method can handle the most complex regions of space-time. It is this success that fuels their proposal to point this powerful lens at the ultimate unknown, the beginning of time itself. In their view, questions once relegated to the realm of speculation are finally becoming testable hypotheses, moving our cosmic origins from theory into the laboratory of the supercomputer. Alrighty then, I am going to take a rest from talking because I am just about there. I'm going to throw up Tamitha, and I'll get rid of me there first. No, that's the wrong one. There we are. Get rid of that. And oh dear. And okay, stand by for Tamitha Scove, Space Weather Woman. And here she is. So let me see if I can get this going right. I have to press this button, I've got to press that button, and stand by.
We have 2 solar storms on their way to Earth, a lot of flare potential, and new regions keep emerging on the sun's far side. Those stories and more are in the news this week. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week is getting very exciting. As we take a look at our Earth-facing disk, we're going to be paying very close attention to this cluster of regions right here. But before we talk about them, let's talk a little bit about region 4191. This region is going to be rotating to the sun's far side here very shortly, but as it rotated to the hairy edge of the Earth strike zone, you can watch it give a little puff right here, poof, right there. That, believe it or not, was part of a solar storm launch. In fact, as you watch up here, you can see a little bit, back it up just a little bit, you can see a little bit of glowing arcades right there. All of that was actually a solar storm that's gone mainly northwest of Earth, but it's on that hairy edge of the Earth strike zone, so we could get clipped by it. But that's not the only story. We also have been following a lot of active regions. We've got regions here as well as filaments, and they're all kind of interplaying together. In fact, as later on in that same day after the 4191 launched a solar storm, look at this little filament right here that's kind of anchored in region 4199. You'll watch it partially let go, boof, right there. Nice eruption. Doesn't look like it's all that big a deal because the filament didn't really let go, but believe it or not, that's also an Earth-directed solar storm. In fact, it was a bit bigger than we thought it was. From the disk images, we wouldn't expect to see a total massive halo like this, but we sure got one. In fact, one of the M2M forecasters who had to fit it said it looked like an inverted triangle, or maybe a carrot if you're actually kind of squinting. Anyway, I said it was a very interesting observation because actually, when we take a look at the blast wave that came up from this, you can see the beginning of this blast wave in different base difference images here. You're going to watch this blast wave spread across the disk. But here we go. As it does that, you can actually even see it reach all the way up to this region up in here. But as you watch it continue to evolve, you see that it begins to have some darkening areas around the perimeter over here all the way around. And isn't it interesting that as you look very closely, this almost looks like an inverted triangle, very similar to what we see coming out of the coronagraph. So what that tells us is that this whole region in here was likely evacuated by this solar storm. So it wasn't just a small blast in here, but a much larger part of the corona let go. So that's why we saw such a big coronagraph signature, and why we could end up seeing a much bigger solar storm at Earth than perhaps we expect. Now, as we continue looking, we also are watching this big filament here to see if it's going to let go. It has been actually involved with this whole cluster right here. Again, you're seeing lots of filaments being involved with these active regions. And if we take a closer look at the cluster of filaments, we're actually seeing an interesting phenomena that always seems to develop right around this time in the solar cycle. We start getting what I call these core filaments, really a lot of them being exposed. And it's showing here, you can see the core filament that was here with this is the one that actually erupted from region 4199. But you see this kind of an S shape here that goes like this, region 4202 and 4201. You also see core filaments in here and even in here. And the thing is, with these core filaments, if they actually launch as solar storms, it's incredibly dense structures that we launch out, oftentimes coming with radiation storms as well. So we don't even need these big, massive flares and high-level radio blackouts to get some really strong solar storms launched. So we're going to be paying very close attention to these regions in the future, especially the ones that have these core filaments, because they could have very strong storm potential, especially when they're complex structures like this. And that also includes region 4205 and 4206, because you can actually see a core filament in there as well. So let's keep our eyes on these regions. And now switching to our sun's far side, we use stereo A imagery because stereo A has finally moved far enough in its orbit around the sun to stare at the sun from the side. You can see here's Earth, here's the sun, and here's stereo A. Look at that, staring pretty much from the west limb, which is really nice because as we set this in motion, here's region 4193, and you can see it launched a big far-sided eruption. This actually was a pretty big structure in coronagraphs, and it was kind of hard to tell whether it was going to be Earth-directed or not. but luckily stereo A gives us the imagery we need to be able to tell that it's not an Earth-directed solar storm. What we also watch and want to pay attention to is region 4203. This was a region that was growing just as it, and kind of emerging on the sun's disk just as it rotated to the west limb, and it sure looks like it is continuing to grow. It might very soon will be a solar storm producer here. So we've got to watch this on the other side as well as we take a look at it from solar orbiter's view, because this could be a big player very soon. And now as we switch to our full sun map, we are very fortunate to still have solar orbiter on the sun's far side. In fact, as we take a look at that same graphic from last segment, you can see here's Earth, here's the sun, here's stereo A, but now you can also see solar orbiter in a great position to give us a full view of the sun's far side. So as we take a look at this map, in red you will see this is the front side of the sun that we can see from Earth, and then here in blue is the far side. This is what solar orbiter sees. And so as I set this map in motion, one of the first things I want you to see is that we've got some new regions in here, especially region 42, 07, 06, and 05. Watch these regions really begin to grow over the last few days, right before they began to rotate into Earth view. So this is a big deal because these regions now have just rotated into Earth view and they look to be extremely active. And now we know why. It's because they're brand new. So amateur radio operators and emergency responders expect to get radio blackouts from these regions. We also could see them as solar storm launchers. We're going to have to be paying very close attention because new regions are oftentimes the most volatile of all. We also have another region here that's going to be rotating into Earth view probably in about 2 or 3 days, and because it is a new region, it also could give us big radio blackouts. So we're going to have a lot more activity over the next probably week or two before things kind of calm down a little bit. We're going to get another coronal hole here in about, we'll start seeing it in about a week, but it won't reach the Earth strike zone for quite some time. But as I take a look at the other side, so this is the west limb now, once again in Earth's view, you can see region 4203. Let me back it up just a little bit because this region just started emerging as it left the west limb. You can see right here back on like the 25th and 26th, that's when this region really started emerging. So it has been growing and we've watched it from stereo A's perspective, and now it's beginning to rotate into solar orbiter's view. So we're going to be watching it on the sun's far side because this could definitely be a big solar storm player as well as a big flare player. And now returning to those Earth-directed solar storms, we switch to our solar storm prediction model, ENLIL. Now this is NOAA's version of the model. The top panel's density, the bottom panel's velocity. You're looking down at the sun from the North Pole with Earth being off to the right. And as I set this solar storm model in motion, you're going to see 2 solar storms being launched right here. The first one is that one that's going mainly northwest of Earth, but then you see that much bigger, faster one. That's the one that was launched by region 4199 and had that inverted triangle kind of halo signature. So you can see as they begin to get close to Earth, they kind of catch up and almost merge. Now that's not what really happens. You're just going to kind of compress them both. But because it's kind of a 1-2 punch here, the chance for the solar storms to be a bit more intense is pretty good. So NOAA believes that we should be getting an impact right about 2100 UTC on the 1st, so late on September 1st, possibly into the 2nd, but we should see some activity begin to ramp up just a little bit. I believe that first solar storm is probably going to give us kind of a mild impact, and then it'll really start ramping up. So if there's a mild impact at first, aurora photographers, you just hold on because we probably are going to get a much bigger impact shortly thereafter. So expect storming to come down to mid-latitudes. We could see G2 plus possibly G3 levels on this one. Now as we switch to our NASA's version of the model, they're only showing the one solar storm, the fast one, but they've got this one impacting about 1900 UTC, probably really close to the same time. So aurora photographers, we are getting some good consensus here that this is going to be a decent show all the way through the 2nd, possibly in the 3rd, into the 3rd before things calm down. So be sure to keep your batteries charged. And now stepping outside to take a look at our current conditions with our global geochron map. Over the last 24 hours, we haven't been dealing with all that much in the way of radio blackouts, save the one that we had on the 30th. We had an M2.7 class flare. You can see it right here. It actually gave us a little bit of a radio blackout at the R1 level for the ham radio bands. Wasn't all that bad, but it did last for an hour or two before things kind of calmed down. It didn't have a big radio burst, so it was a bit on the mild side. Outside of that, we've been sitting really just with a minor degradation, pretty much between 5 and 10, maybe 15 megahertz in terms of degradation, a little bit here and there, but not too much. It's just a lot of noisy active regions, but no big pops from really big radio blackouts. Now, as we switch to our ROTI scintillation risk for GPS and GNSS, these are frequencies that are a little bit higher than HF radio. You can see already we're getting big patches of enhancement for risk for scintillation, and this is because of that. We're still in that radiation storm that we've been ongoing for quite a few days now. The radiation storm has calmed down just a little bit, but man, the scintillation risks continues to be high. In fact, not just on the night side, that's a big deal, but even on the day side, you can see a bit of scintillation risk increasing, especially anywhere near those big storm systems. So if you're a maritime traveler and you're using sat nav, expect to get a little bit of issues even in the on the day side of Earth. But that's likely going to calm down once this big solar storm passes, but you're going to have to hunker down until that time. Now, as far as aurora is considered, well, we're really not dealing with much aurora right now. So aurora photographers have kind of had to sit there and just wait for a little bit, but this is definitely going to change here over the next 24 hours. Now, switching to our moon, we are now passing through the first quarter phase on our way to a full moon, with a full moon being on the 7th. But by the 6th, the moon will be about 98% illuminated. So, night sky watchers, if you want to catch those dim objects in the sky and maybe some aurora with this solar storm, well, this bright moon is going to be a contender out there. So you're going to need to check your local rise and set times. And now switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating the 1-2 punch from those two solar storms that are headed toward Earth. At high latitudes, NOAA is expecting severe storm conditions. This is starting right around the 2nd, but we're going to be ramping up right around the 1st because we do have that first solar storm that's going to be a little bit more mild. So expect to be able to chase, if you're an aurora photographer at high latitudes, possibly through the 3rd before things calm down. But then it's only going to calm down for about a day or so, because after that we're going to be looking for that fast solar wind that is from that coronal hole that is just rotating into Earth view now. So aurora photographers, it looks like it could be a very good week for you. Now at mid-latitudes, well, we're still expecting major storm conditions, not quite as strong a storm, and it's not going to last quite as long, but we still have a very good chance for aurora as long as that magnetic field orientation is pointing the right way. So if you're a mid-latitude aurora photographer, it might be worth a look. And then yes, starting around Friday, we are going to be watching for that fast solar wind that could start picking up right about then. And now switching to our solar flare and dayside radio blackout outlook over the coming week, we are still sitting around 200s, a little into the 210s right now for solar flux, and that's likely going to continue. We're sitting at severe noise on the dayside radio bands. In fact, if you're an amateur radio operator, I'm sure you've heard it. It is pretty noisy out there. The X-ray flux is well above the seafloor. NOAA's giving us about a 65% chance of M-class flares at an R1 to R2 level radio blackout, and 20% chance of X-class flares at the R3 level radio blackout. That is easily going to last for the next 3 days. I'm pushing it out to even further than that because we've got quite a few regions on the Earth-facing disk who look like they could be big flare players if they just make up their mind to do it. And now switching to our radiation storm and polar aviation outlook over the coming week, we are sitting at the D2 minor range right now. This is at flight level 360, and we're likely going to be lasting there at least for the next few days. This is also the S0 range for everyone else at the moment, but we are sitting at elevated fluxes right now, and likely we're going to pop up very close, if not touch the hairy edge of an S1 radiation storm, and this is because we've got that big set of solar storms headed toward Earth, and as they pass over Earth, that's likely when the radiation storm is going to peak. I'm giving us about a 20 to 30% chance that we'll get up to an S1 level, but it's going to dip down shortly thereafter. So hang in there if you are dealing with this. If you're a high-risk passenger or a frequent flyer or your air crew, be sure to pay attention to those ICAO advisories because things could change quite quickly. And if you're a GPS user, well, careful with the high latitudes because that polar cap absorption event is still ongoing. So the space weather this week is getting very exciting. We have that 1-2 punch of solar storms on their way to Earth. Aurora photographers, we could get shows clear down deep into mid-latitudes with this one, so be sure to keep your batteries charged. Now expect to see something starting around midday on the 1st. You could start seeing a little bit of a ramping up of activity, but by the 2nd, things should be pretty good. And then, of course, if the magnetic field orientation of the storm is the proper way, things could last possibly into the 3rd before it calms down. Now, amateur radio operators and emergency responders, well, we've got a lot of noise on the dayside radio bands. We have the radiation storms at the poles that's giving us some noise, and now we're going to have a solar storm on the night side of Earth. So pretty much all around the globe, things are tough. You just kind of hunker down and last through the next few days, and things should get a little bit better. And now you GPS users, well, risk for scintillation is really high right now, especially on the night side and on the day side anywhere near storm fronts. And of course, anywhere near Aurora, once that solar storm hits, that's going to be a problem too. Dusk and dawn are never good. So, right now, GPS might be a little bit glitchy for you right now, no matter where you are. So be sure to stay vigilant. And if during that solar storm, be sure to calibrate your magnetometers often. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Right, thanks, Tamitha. It's like so. I played that mostly for historic reasons because it's mostly covered the last few days. But if you are into shortwave listening or DXing on the HF, you'll probably be able to relate to the way some of the conditions have changed through the week, and there's the result. All right. Now I'll just briefly go into what spaceweather.com has to say right at this very point in time. So let me just bring up the sun. This is the current disk of the sun. If we were to look at it right now, there's the placement of sunspots. And the solar wind is currently at 402 kilometers a second at a density of 4 protons per cubic centimeter. The current sunspot number is 150, and the radio sun solar flux units is 172 solar flux units measured at a wavelength of 10.7 centimeters. The current auroral glow over the Antarctic is looking like this at the moment, so it's a 50-50 thing, maybe a bit less, but it's not much to write home about. You wouldn't be seeing too much. The coronal hole is present in the sun at the moment, so there'll be lots of high charged particles streaming from that hole. And the sunspot cycle is looking like this at the moment. If you missed it last week, here it is. So that's where we are on the scheme of things with the solar cycle. So we're definitely on the decline now. As far as space weather goes, what else do they say here? What's this? No, I won't bother reading that out. There is a reference here to the comet, the blue tail of Comet 31 Atlas. There is a GIF image associated with this article. I'll just run that and loop it. So the object you see in the center of the screen is the comet, and they're saying that the tail of interstellar comet 31 Atlas is faint, far away, and notoriously difficult to photograph. Amateur astronomer Michael Jagger has discovered the trick. He says, use a blue filter. He says, on August 28th, he and colleague Gerald Riemann captured a movie showing the comet's tadpole-like tail pointing almost directly toward the sun. This is the first time amateurs have made such a clear detection. The idea came from reports that 31 Atlas is unusually rich in CO2, much like comet C 2016 R2 from our own solar system. Blue filters had proven very successful with C 2016 R2, which had similar composition. So we tried the same with the Atlas, and he says comets with a lot of carbon dioxide tend to have blue tails because of photochemistry. Solar ultraviolet radiation breaks CO2 into CO+, which emits blue light, and that explains the colour but not the direction. Normal comet tails are blown away from the sun by solar wind, and the radiation pressure 31 Atlas tail is pointing towards the sun, a twist that astronomers don't quite fully understand. But there it is, right in the middle there. That's rather fascinating. All right, that's spaceweather.com in a nutshell. Where is it? As of September the 5th, 2025, there are 2,349 potentially hazardous asteroids. That's a figure that hasn't changed too much over the last 5-6 months or so. Alrighty then, on that note, I shall conclude, if I can just find my camera. But before I do go over to 3541 kilohertz, I'm going to do a quick show and tell. For those that know, I have been waiting for a pillar, a metallic mounting pillar, to arrive for my scope dome so I can mount the telescope. Well, courtesy of sidereal trading in Tullamarine, they have finally sent my pillar and an adapter plate. And let me show you live on camera what I am talking about. Firstly, this is the adapter plate, which is quite heavy. That's pretty thick aluminium there, all anodized, and that's by Astroworks, which is a division, so to speak, of sidereal trading. Astroworks is where they make telescopes, and they've got full machining workshop to be able to do this. They make this stuff. So good on you, Diego. He's a machinist. So that's an adapter plate. Now, why do I need that? Well, because I am using one of these as a mount for my telescope. That you see on the screen right now. That is my equatorial computer controlled motor control system for the telescope. And you can see at the bottom of the mount is a tripod. Now, basically, when you buy telescopes, you know, it comes with a tripod, and your motor control system is mounted on top of that. Well, I've got no room for a tripod in my dome, so the idea is to mount a pillar in the center of the dome, so the equatorial mount can go onto the onto a pillar, and that's what this is doing. So this mounts on top of your pillar, and that motor control system that you just saw is mounted on this and locks in place perfectly. So that's an adapter plate that AstroWorks makes up, and the actual pillar itself is this contrivance. There it is. That's also made by Sidereal Trading, and let me just readjust my microphone. And that's what I've been waiting for since since about May. So that that's the bottom of the pier, and that mounts directly to my concrete pier, which is just underneath the dome, poking through the door, poking through the floor of the dome, and that bolts, dynabolts to the concrete. So that's 600 millimeters long, and the telescope mounts on the top of this. So, and the adapter plate goes on top of that as such. So there it is, ladies and gentlemen. I have been waiting for this to finally come along, and I will bolt that maybe this weekend. I don't know yet if I'll get there, but I'll get that bolted to the centre of the dish, centre of the telescope. Struth. And then I can take my mount, the motor control system, this and mount that in the middle, and then mount the telescope. Now I have 3 telescopes. There's the 8-inch Celestron, which is already on a fork, so the telescope sits in the middle, and I'm thinking of deforking the telescope, so the actual Celestron Schmidt-Cassegrain telescope is mounted on this motor control system. So that alleviates a few things. And the other telescopes are 12-inch Newtonian and a 6-inch refractor. So we're getting there. We are getting there. It's essentially looking like this. That's somebody else's dome, but that's basically what I'm talking about. A pillar in the middle, a concrete pier poking through the deck of the floor of the dome, and then you have the mount on top of that. So that's essentially how it's going to look. And then I can get serious with doing some astrophotography and whatnot. I haven't got the cameras yet, but that's the next thing. Alright, I thought I'd just show you that. I've run out of time for the other articles that I had here. It's amazing how quick 60 minutes goes. So I shall pass those over till next week. Now, I'm going to go across to 3541 kilohertz to see if there's any stations wishing to check in. But I'm just as a forewarn, those who are watching my video streams, YouTube and Discord, the vision may drop out, because even though I've been waffling and carrying on for over an hour and the modem hasn't fallen over, as soon as I start intermittently transmitting, you'd think that a sideband transmission would be something similar, but as soon as I actually start intermittently dropping off and picking up you guys on the frequency and talking back to you, that switching action for some reason upsets the modem. So you may lose vision. So if you lose video, it's because, well, not so much lose video, but if I lock up, that's because I've lost the internet, and I'll know when that's happened because it tells me on the computer screen here. All right, having said that waffle, let me get my piece of paper here ready. And this is VK3EKH, having a quick listen on 3541 kHz for any stations wishing to check in. Alright, VK3SBX, VK3 Delta X-ray, excuse me, VK3KIS, oh dear, VK3BSE, and VK5 Whiskey Alpha. Any other stations?
VK3AOB, casually listening.
All right, and acknowledging VK3AOB, occasionally listening. No, I know you said casually. Casually. Struth. All right. The top of the list is Steve, VK3SBX, VK3EKH.
VK3EKH, this is VK3SBX. Okay, Clint, you did well to take all those call signs down in quick succession there.
Used to it.
Very good job. Yeah, okay, well, interesting stuff as usual. I did make out a little bit because I was playing with a new radio here. But, yeah, that, the comet, there at the end, that was pretty interesting too. I've never tried that. I don't know, not enough time to do all these things, but I'll maybe get around to it one day. And good to see you've got the pier and the established place there, Clint, so we expect progress now. Now that's where it starts to get complicated, actually. Now
Yes.
you have to get into all the software to actually make it work. And, yeah, that's a whole other thing, as you'll no doubt find out pretty damn soon. Anyway, it's a very interesting journey, though, so I'm sure you'll have lots of fun with it. All right, I'll get off and get someone else to turn their clip. VK3EKH is VK3SPX.
Yeah, thanks, Steve. Good on you, mate. Yeah, it is. The journey now starts. I've got so many books on astrophotography. It's like a library. It's like my radio astronomy library. When I was well and truly into the radio astronomy journey, which has started, 25, almost 30 years ago, I went crazy getting books on radio astronomy. I really wanted to cover the historic aspect to radio astronomy with books that were published in the 50s and 60s, and then some of the heavy technically orientated books, which is really the astrophysics is beyond me, but anyway, it's part of the library. So now it's the optical side of it I'm collecting, and we're getting there on that. Anyway, yeah, all good fun, and yeah, I just can't wait to be able to start getting the telescope finally fitted and watching the dome move with the telescope, and then being able to sit back in the warmth of the astronomer's office upstairs, using the whatever software to be actually able to see these objects form in front of my eyes. Anyway, we'll see. All right, thanks, Steve. VK3 Delta X-ray, Greg. We're on a bull. Have a say, VK3 EKH.
Yeah, good on you, Clint. VK3EKH, VK3DX. In Warrnambool, as you said, wonderful. You're all good, mate. Very interesting, and I like the dome and the telescope and the mounts and everything there. That was, yeah. I wonder, Clint, are you going to remote that, or are you going to be in that dome? I'm just wondering. I've sort of got no idea. I'm not sort of a telescope person by any means. I know very little about them. I know what they are, but that's as much as I know. So, yeah, good evening everyone else on there. What else, Clint? Yeah, I didn't get on last week. The wind blew the antenna down, or part thereof. But anyway, we got that fixed up on Saturday. Out by Sam SST sorted that out for me, and yeah, we're back on the air tonight. So your signals 5 and 9, and Sam's watching on Discord, so there you go. It's all happening here in Warrnambool, Clint. VK3EKH, VK, and very interesting tonight. VK, I've been watching on YouTube as well. VK3 Delta X-ray, Greg in Warrnambool. Thanks for running that, Clint. Great job.
Yeah, good on you, Greg. VK3 Delta X-ray, VK3 EKH, VK3 CSJ on the microphone. No worries, Greg. Yeah. What was the question again? Yes, remote. Oh, yes, most definitely. I think the first time that I went out on a to a dark sky site, it was somewhere in Gippsland, and I wasn't dressed for it, and I wore runners. As you do, it's nothing unusual. You wear runners, but the thing that I found, being out in the middle of a footy oval, with all these telescopes set up, the first thing I found uncomfortable was I could feel the cold of the ground through my feet, and of course you felt the chill. So I might have been wearing a thick jacket, something like I've got on now. But footwear is something you have to consider if you're going out into a dark sky location. Anyway, what I'm saying is that now that I've got the dome set up, I was out there a few weeks ago. I was out till 4 o'clock in the morning doing some manual work on the Celestron telescope, and I was fighting dew forming on the lens, the objective lens of the telescope. Every couple of minutes I'd have to wipe the moisture off the front of the telescope, and it was annoying me because it was stifling what I was wanting to do. And the more that I was out there, the colder things were getting, and there was a layer of fog, mist coming in across the floodplain. And I knew fairly quickly that being able to view anything was going to be not possible. So it was freezing, is what I'm saying. It was overly freezing, and I thought, who in the hell would be an optical astronomer? My God, it's so cold. So no. From the word go, from the moment that I took on this astrophotography idea, was to certainly have a remote setup, and the 3-meter scope dome, which was a pretty major purchase for me. The 3-meter scope dome is totally remotable. It is designed to be connected to a computer system, so that from a remote location, whether it's just down the backyard or hundreds of kilometers away, you can remote the dome so that the shutter opens, and you can close the shutter, and the whole system rotates with your telescope, and you can have it so that there's sensors fitted to the dome so that it detects moisture and cloud cover. So if you're doing an observation run and clouds suddenly start to come across and stops your observation work, the system will automatically close down, close the shutter, so that if there's any rain, nothing gets damaged or nothing gets wet. All that is automatic. So my plan is to be able to sit here. Well, the astronomer room is upstairs, but in the comfort of the warmth of my computer, where the computer is, and be able to use a fairly decent camera on the telescope. And yes, it's very successful. People are doing it everywhere, almost. All right. Thanks, Greg. Thanks for watching on the video streams and the report. You're also about almost 30 over 9, so coming through very, very well indeed. Next on the list is Andrew, VK3KIS. Good signal from you, Andrew. Go ahead.
That can be your first target with the observations. Anyway, thanks for doing that, Clint, and we'll catch you down below. VK3EKH, VK3EKIS73, mate.
Thanks, Andrew. VK3KIS, VK3EKH. Now, I'm not aware of an eclipse occurring this month. I'll check that out. What I am aware of is that there is a blood moon on Monday, a so-called blood moon, which is this Monday. I think that's happening around 4 a.m. in the morning, though. I'm just reading a note from Sidereal Trading. This is from Bill Stent, the telescope gent. He says here that I'm always whinging about how the media beats up astronomical events. He says raising expectations to fever pitch, he says. However, next Monday morning at around 4 a.m, you should probably get up to see a total... Oh, okay. Okay, yes, you're right. He says total lunar eclipse. Oh, excuse me, I'm losing my voice. You're right, Andrew. I only partially read this letter note from Bill, but yeah, okay, blood moon, because it's an eclipse. All right. However, next Monday morning at around 4 a.m, you should probably get up to see a total lunar eclipse setting in the west. Blood moons really are cool, he says. This is a photo there's a photo here of a blood moon, which I didn't grab. But all right, yeah, you're quite all right, Andrew. There it is. I stand corrected, I suppose. I don't know if I'll be getting up at 4 a.m, although I'm known to still be up at 4 a.m. But that's Monday morning, and I'll be going to work, so I may miss it. But yes, if I can get my system, I don't think it'll happen though this weekend, but if I can get my system up and running that quickly, I might be able to do. No, I might be able. Oh, I don't know. No, I'm not sure. No, there's not enough time to set it up. There'll be plenty of other blood moons. All right, thanks for that one, Andrew. I've made a note of that. Excellent. All right, next on the list is John, VK3 BSE, VK3 EKH. Tell me about it.
Anything else? I can't think of anything else important to say here for now, so I'll end it back. VK3 EKH, VK3 BSE.
Yeah, thanks, John. VK3BSE, VK3EKH. Very good. Yes, these eclipses, like the lunar eclipse, you're quite right. It starts a few hours before totality, and the same afterwards. It takes its time afterwards. Unlike a solar eclipse, the moon passes in front of the sun pretty quickly, and the shadow that's cast by the moon can move very quickly as well. A completely different kind of eclipse, but with the moon, because it's the Earth's shadow that falls across across the moon, and the Earth's a bit bigger than the moon, so the actual shadow that's cast is you're right, quite right. It takes a while. I many years ago I did a radio astronomy experiment where I had an old a satellite dish antenna, and I had a KU band LNA and an old analog satellite receiver. And what I wanted to do was to measure the thermal drop in radiation, the black body radiation from the moon, as the surface temperature of the moon dropped during totality. So before the eclipse started, I think this was around 2004, something like that. There was a total eclipse which occurred around 10 o'clock at night. So I got out there pretty early to capture a fully illuminated moon. And what I actually really wanted to do was to connect a chart recorder to the output of the satellite receiver, but for the life of me I couldn't get the chart recorder to work properly. So I thought, bugger this. What I'll do is I'll take a measurement, a voltage measurement across the signal meter, the S meter that was in the satellite receiver. I'd measure the voltage across the S meter every 5 minutes. So for over 2 hours, I actually a bit longer than that. Every 5 minutes I would re-peak the signal on the S meter, looking at the moon, because it was quite a significant rise in noise. And I took a voltmeter measurement and wrote it down on a piece of paper, and I did that religiously for quite a few hours, because what I wanted to do was to capture full luminosity, full totality, and then full luminosity, so I could chart that dip in thermal radiation, black body radiation, and to look at the what I wrote down on the piece of paper, you wouldn't see the variations in voltage. But it's not until I plotted it into an Excel spreadsheet and took a polynomial curve of that data that you actually saw it. This beautiful, the curve it came across and then dipped and then came back up again. And I thought, isn't that magnificent? You have to be keen. That was just one of my little experiments in early radio astronomy, black body radiation from the moon during a total lunar eclipse, which was an article I wrote in the one of the ASV magazines back in early 2000s, I should say. Anyway, enough of that nonsense. Thanks, John. Dallas, VK5 Whiskey Alpha, VK3 EKH. Go ahead.
That big pillar looks fantastic. I presume, from understanding, that it's sitting separate pillar to the rest of the room, I suppose, or the floor. That's the ideal, I suppose.
Yep.
Our broadcast received well here, and other variable levels, a bit difficult to Australia here with the noise I got. But, thanks again there, Clint, that's great. Anyway, cheers there, catch you next time. VK5 Whiskey Alpha.
Good signal coming in. You're 25 over 9. VK5 Whiskey Alpha, VK3 EKH returning. Oh, oh, excuse me. Yes, it is. I'm just trying to find that picture that I have of that. Oh, there it is. Yeah, I'm not sure if you. Oh, yeah, well, I suppose you are viewing. But that image on the screen right now is of somebody else's dome, but it basically shows you what I'm doing. I'm going to see if I can zoom in on the center part position. Alright, so just zooming in on that, you can see the concrete pier coming through the floor, and the deck is completely the whole central pillar is isolated from the dome. So you've got this massive concrete block in the ground and the pier mounted to the concrete block. So you could have a party going on inside the dome and technically there won't be any vibrations transferred through to the telescope. So that's the whole idea of that. So that's basically what I've done, is I've got that concrete mass in the middle of the dome, and that pier that I held up before will be bolted to that. So that's all for the purpose of doing astrophotography, because you want absolutely crystal clear images, and you don't want any kind of vibrations to go through on the telescope. But having said that, the fact that I am going to be remoting my work means that I won't be in the dome anyway. So there'll be minimal vibrations because of that. I won't actually be in there, not all the time at least. So, but I mean, you've got a bit of a windy night. Even if the wind blows a little bit and the dome kind of vibrates, that won't transfer through to the telescope. Well, at least I hope it won't. Anyway, we'll see how that all goes. Thanks, Dallas. Now, Britt, do you want to contribute anything? Because you're only occasionally listening. VK3 AOB, VK3 EKH.
Yes, sorry, Clint. Evening, gents and listeners. Yeah, there you go. I was watching a movie on the ABC and it got me in, and it was distracting.
It's all right. That's okay.
I've recorded the whole thing on the 7300, so I'll listen to it back tomorrow, but sort of here and there, and as usual, you've done a great job.
Thank you.
I'm sitting here editing photos and trying to figure out how to shrink stuff down to a small enough size, and it's harder than you would think. Anyway.
Shouldn't be.
733 kilobyte, that's not bad. Yeah, so there you go. Yeah, no, it was job well done, and keep up the good work. Back to you.
Thanks, Brett. VK3 AOB, VK3 CSJ, Not a problem, dear sir. Thanks for calling in. You're about 30 over 9. Very, very powerful signal. Not a problem at all, and absolutely superior audio. Yeah, it can be a bit of a trick if you haven't done it before. It depends on which Windows or what computer program you're using, but reducing the size of images can be complex. But if you're inserting an image in an email, it's generally not too difficult to do. A lot of, the email that I use, you can just insert the image and then drag it to a suitable size within the email, and it's easy to do. But anyway, you'll work it out. It's not too much of an issue. Okay, on that note, thanks for the kind comments, everybody. Is there anybody else wishing to check in tonight? I would have thought that Mr. HK would have been there, but he's probably gone to sleep listening to me. Anyway, all right. On that note, it's 20 minutes to 12, so thank you very much for tuning in. Like I said, I was that close to not coming up tonight. I thought I'd give it a bit of a break, but I thought no, I'll still show up. I can always find articles to talk about. Anyway, this is VK3 Echo Kilo Hotel in Narrewarren South, concluding transmissions tonight on 80 metres and everywhere else. It's nice to see that my video stream hasn't fallen over, so that's good to see. And we'll see you all next Friday. Don't forget the lunar eclipse this Monday morning at around about 4 a.m. So you can start watching it from about 1. And of course this coming Wednesday is the Astro Talk from ASV, Professor or Dr. Jacob. I forget his surname right now, but Dr. Jacob. Where is it? Astro Talk. Crossett. Dr. Jacob Crossett talking about jellyfish galaxies. So I will pick that up, if I remember, I will pick it up on Wednesday night and stream that over YouTube, over the A2V repeater. It'll go for about an hour at least, I'm sure. But there's links, if you go to the calendar on the ASV website, there's the YouTube link is there, and the Facebook link is there, and there's also a Twitch link. Twitch. All right, have a good week, everybody. Weather is going to go south on Sunday, so happy Father's Day. Yeah, from Sunday onwards, it'll be touch and go with the rain. So tomorrow is going to be the best day out of this weekend. Cheers, everyone. Take care. VK3 EKH, which VK3 CSJ on the microphone concluding. Cheers, everyone. Take care. Yep, thanks, Craig. There it is. All right. Well, on that note, I think I will conclude on the video streams. So let me bring up. This is the current view of the All Sky Cam up at Heathcote, and as you can see, it's still pretty miserable looking. You can't see any stars. If we get rid of the that, I don't know. The moon, unfortunately, the moon is too bright, and it's ruining the view of the All Sky Cam. And there's a bit of moisture on the dome, so I can't really see too much. But anyway, all right. This is VK3. Where's my camera? I've lost my camera now. There we are. This is VK3 EKH, now VK3 CSJ, concluding, and I'll be back again on Sunday morning with the WI broadcast, and on 160 metres, and then on RTV, and then at 8 o'clock on Sunday night. So with that, cheers everyone, take care, and look after yourselves. This is VK3 CSJ.